my name is Glenn McLean, WA7SPY. So the first presentation we're going to do, I'm going to talk about something called AllStar. And what that is the technical name is ASL, or AllStar Link. And it's a Raspberry Pi that's interfaced to a radio. And it needs the push to talk, transmit audio, receive audio, ground, and what's called COS, so that the Raspberry Pi and specialized software knows that the squelch is open, so it'll start receiving audio. So imagine the radio you have in your mobile or your walkie-talkie or whatever hooked to a computer, and that's essentially what the setup is that I'm explaining here. And there's other ways to interface it. Some people, and we'll probably do that eventually here with ours, but I interface the Raspberry Pi directly to the repeater controller, so you don't have to have a radio to go through. But right now I have mine set up to go through a radio that's on the west repeater, the east repeater frequency pair, and it works quite well. So it also allows you to have Echolink. How many of you are familiar with Echolink? Okay, quite a few of you. So what Echolink is, there's an app you can get for your Android phone or your iPhone, and it's called Echolink. So it allows you have to register your call sign with them. It's free, but it takes a few days to get registered with it. You go to you go to echolink.org, and then you ask for a call sign validation, and they will send you the credentials, and then you have the app on your phone. And so what you can do is you use your phone, and it accesses either over the internet or it'll access through our local repeater here. So it's a way to talk on the radio via your phone. So it's a two-way thing. When somebody's talking on the repeater, you can hear the repeater on your telephone, on your mobile phone, or you can talk on your phone and go the other way. So that's pretty cool. Yeah. So it's an internet-based linking system for amateur radio, repeaters, nodes, and you can also, it's real popular, people take the little Bofang radios and hook a Raspberry Pi to them so they can walk around their house with an HT and get on the internet with it. I'll show you a picture in a minute, but the cool thing about it is there's these nodes all over the world, so you can go over the internet and talk to foreign countries on it, other licensed amateurs throughout the world and across the United States as well. So it's using Asterisk, which is an open source PBX software to create radio to radio or radio to internet links. It's a popular software platform. It's open source, and it's been around for quite some time. And so they've specialized it to make it work with the AllStar link. And it works with the other component you need is it's a standard FM radio, and then the interface device. And you don't have to use this, but DMK, I forget what they stand for. It's an engineering company, and they make what's called a URI. And the URI is the interface between the Raspberry Pi and your radio. And it's got a built-in sound card as well, which makes it really nice. So you connect to a local AllStar node via an interface with the URI or however you did it. I've actually made my own little URI with components on a piece of copper circuit board material, and it worked. And then I bought a cheap sound card and wired it all up, and it worked. The node Raspberry Pi running ASL3, that's the latest software version. The old one was called Ham VoIP, but now it's ASL3. So that's what it encodes and sends audio over the internet. And then other nodes are connected, and they receive and play the audio on the radios. And you can either do a direct connection or you can go node to node via large hubs. So it can be kind of like a conference setup. So what we have for the Chico Gears is it's a Raspberry Pi 4B running ASL3, the latest version. It's got a URI as the interface, and then a custom cable to an Alinco DR135 Mark III 2-meter single band radio. And the reason I chose that radio is it's got a connector right on the back. It's an old radio, they don't make it anymore, but it's got all the ins and outs for the audio, the push to talk, COS. It was designed for using on a packet radio, which packet's still used, but it's not quite as popular as it used to be. But this radio was all set up for it. So since it had the connector, I was able to use the pinouts on the back.
Is that that one radio with that sound?
No,
That's a different one,
that's a different one. So the radio is at my house and it's tuned to the local club repeater and it sounds great and it's fully operational. And then the other really cool thing is, I don't know if you guys are familiar with software or Linux, but there's something you can set up with Linux called cron jobs, and it's nothing more than a schedule to do different things. So I have cron jobs set up to announce our breakfast meeting, our monthly meeting, the Morse code CW class, the Morse code HFnet that Larry runs, and the cool thing is every Friday it'll go get the latest version of Newsline from ARRL, and it'll convert it to the file format I need to make it play, and it'll put it in the right file path, and it'll play Newsline, and they're usually 10 to 15 minute long, and I have it scheduled to do that different days of the week. So yeah, I had it going. Yeah, the audio's awesome, but I did use my service monitor to get it set up. So anyway, so this thing does a ton of things. You can actually use this Raspberry Pi to control a 2-meter repeater, a 440 repeater, whatever repeater you want. It has that capability. Go ahead. The Raspberry Pi has a Wi-Fi chip in it, so it's just hooked up to my Wi-Fi at the house. It's got a Ethernet port on it, so you can hardwire it to a router also. And there are some ports you need to forward to get it to work, so it'll pass the audio and sound. But
you gotta pick up the device.
Pick up the what?
Pick up the device. You gotta pick it up for your internet.
Well, it doesn't. It uses very little, so I pay a monthly fee, and it doesn't even. You don't even know it's there. Go ahead, Kevin.
Help me picture this in my mind. I want to talk to you and know this in Australia. Really going to talk through the repeater, through your Raspberry Pi, go through the internet, over to the node in Australia, and out to their repeater.
Correct. Yep.
And back and forth.
Yes. And the way you bring up the nodes, I'll get into that in just a second. You use your DTMF keypad to command it to get it to do what you want. And so there it is. Newsline, club event reminders. It's easy to remote control via DTMF tones, reliable connection to local and remote repeaters. So you use your FM radio tuned to the local repeater. You send DTMF commands to the repeater to link and unlink nodes. For example, *3, the node number, will link it. *1 will unlink it, and then you just speak normally as you would on the repeater, and you disconnect when finished to free up so you can free up the system again. I can set up a timeout on it, but I don't think there is right now.
That's on 2585?
What's that?
That's on 2585? That's on the 2-meter repeater?
Yeah. 8650. So it extends the repeater coverage via the internet. That's a benefit to our club. I think that's a huge benefit, to be honest with you, because if people would start using it, you can talk all over the place. Some people like to listen to the Alaska WinLink, and I think that's one of the nodes you can bring up. It connects with other hams worldwide, automates important announcements such as ARRL Newsline. We got emergency communications for redundancy, and it encourages members' participation. So, especially people that are interested in, technology and computers, I think it's pretty cool. So if you want more information, you can go to allstarlink.org. That's where you can get all the nodes that you can bring up and take down. And then there's also our local website. Hopefully, we'll have a link to it also. That's in process. Go ahead, Kevin.
You have to be authorized.
You do with Echolink, and I'm not sure about AllStar. You do have to, if you want your own node, you sign up for it. But to use this system, you just have to be a licensed ham radio operator. Nobody checks as long as you got a call sign. I mean, we're all on the honor system with it. So, yeah, we'll just do that rather than go through it now. And if you're super curious after the meeting, just go to allstarlink.org and look up node numbers, and there's thousands of them. And just in case you wanted to know, the node number that we have on the Chico repeater is 45308. And it's under my call sign, WA7SBY. And if you go into the Echolink version and want to use Echolink on your phone, it's under, because they won't allow club calls and stuff. They want private individuals signing up. So it's under my call sign of WA7SPY, and you got to put the -R in it because it's tied to the repeater. So if you're going to use it, you need to use the -R on my call sign. So, yeah, Kevin's been using it, and he likes it. So, does anybody have any other questions? Is this something you guys are interested in, or is it going to be useful to you guys? Go ahead.
We're seeing recently that we use our phones to get on the computer.
That's what Echolink is, yes.
You have to use Echolink.
You have to use Echolink. You can't use just AllStar.
Okay.
What kind of phone do you have, Larry?
Like an Android.
Okay, so you just go to echolink.org, and then there's a thing over on the left in blue, and it says validate call sign, and that's where you sign up.
Okay.
It's pretty simple. Any other questions? Okay, moving right along. We're going to go to the next presentation. So I have a question for everybody. I didn't bring soldering equipment tonight because it'd be hard for everybody to see what I'm doing. But if there's interest in the club of wanting to actually do soldering on RF connectors, or even want to try wiring up and soldering on circuit board material with resistors and capacitors and things, I'd be more than happy to plan a time and place where we could have a group build session, so to speak. So go ahead, Jamie.
One thing we talked about is project. Since I've been in the club, we haven't done a project yet. So either building a tenant, building some little board, maybe something Raspberry Pi related, but it would require high-tech soldering skills. But anyway, think about that. We'll look at together
Die grinder, whatever. So I think it's important that everybody knows how to solder a coax connector on. And I know hams that have been in hams for decades and still don't know how to do it. So don't feel bad, but it's just my personal thing. I think everybody should at least attempt and try and learn how to do it. So this is based on a PL259 connector, which is your standard, mostly used connector to hook up to a radio and antennas. So what you need is you need the RG8 coaxial cable, which is the bigger round stuff. And then it's called a PL259, and you want the male version because most of the connections take a male. They do make connectors for female, but you guys will be wanting the male. You need a 60 to 100 watt soldering iron. And most importantly, you need to make absolutely sure that you're using rosin core solder and not plumbing solder that's acid core. You will ruin whatever you're working on with acid. So it's got to be resin core. And I find 25 to 30 thousandths solder works pretty good, and it comes in different thicknesses. But it'll say resin core. And don't get the water-based stuff. That's garbage. You're going to need a coax stripper, and they do make some pretty cool coax stripping tools that are fairly inexpensive. But a good razor knife will work well. A file or sandpaper, needle nose pliers. Heat shrink tubing's optional. I usually put heat shrink around mine, and a vise or a clamp. So you're going to cut the coax end square, and then you're going to remove an inch of the jacket, but you're not going to cut into the, you'd want to not cut into the braid here, but you need to cut an inch off of here so you have braid and enough for this to stick out. And then you're going to fold the braid back over the jacket here, and then you're going to remove 5/8 of an inch of the Teflon material for the center conductor. And then you're going to very lightly tin the center, very lightly, so it'll still stick through the connector. Very lightly, very, very lightly. Yeah. You're just doing it so that the solder will flow to it when you solder the center of the connector. So then you slide the shell onto the coax, and then you're going to screw the body of the connector onto the coax, and you'll know it's screwed on far enough because you'll be able to see the braid through all the holes, and that's what you're going to solder. And then the center conductor should protrude slightly through the center. If it protrudes a lot, it's not a big deal. You can cut it off. But if you're careful, you can make it to where it works. So you want to make sure, and this is the hard part. You want to make sure your iron is really hot. It takes a lot of heat to solder these things. The center pin is going to get soldered first, and you want to fill that whole center pin up with solder until the hole fills. And that way you know you got a good connection. And you want to do it fairly quickly because, Chris, did you have a question? You can put flux in there. I never do, but I've never had any trouble not putting it in there, but it's optional. You can. And then you want to solder the side holes, heating the connector body. And this is where the hard part is, because I've seen people where they don't heat it up enough, and then the solder's just globbed in there. And that's not a good solid connection, and that's going to cause you all kinds of grief and issues down the road. So it's a balancing act. You want to get that hot enough to where the solder is going to really flow nicely onto the braid and onto the metal part of the connector, but you don't want it so hot that it's just going to melt the whole coax and short it out. So it takes I would recommend a soldering gun works really well for doing that. Or one of these big soldering tips, yeah, because that thing absorbs a lot of heat. But once you get it hot, you'll know it because you'll put the hot solder in there and it'll just flow right in. Well, yeah, you would put that on. Yeah, you would put that on first and slide it way down out of the way of where you're heating. So.
One of the problems I've had doing this is using a soldering iron that's really for surface mount stuff.
It's not going to cut it.
Yeah, you end up melting things
Yeah. So the idea is to get it hot and get out, in and out, and without damaging anything. Yes. Yeah, it's
Is there a certain temperature? Now, I know you want to get it hot, but you want to.
I just start heating it up until I see that it's flowing, and then I know I'm good. So just crank it up and get it to flow, and you're there. So you want to, as I just mentioned, you want to avoid the overheating, because then you're going to melt the dielectric on the center, and now you've got a shorted coax. So that brings me to the next slide. You want to check your solder joints, and you want to verify continuity with a multimeter, and then you can put the shell back on. You can do coax seal or heat shrink if you're going to do it outdoors, but as the gentleman mentioned, make sure you put your heat shrink on first before you solder. And that's another, I always have a big wet sponge, so you want to drag your hot soldering iron into the sponge and clean off the tip with it, and then put solder on the soldering tip so you've pre-tinned it, and you do it every single time. Otherwise, you're not going to get the solder to flow like you need to. Rosin core only, keep the coax ends clean and dry, and most importantly, buy some extra connectors and practice on a piece of scrap before you go for the real thing, if you've never done it before. So I've got some handouts, but you also want to definitely do some checking after you get done. You want to check from the connector to ground and make sure you got continuity there, and then you want to go ground to the tip and make sure you don't have a short. And you need to do that on both ends, and you go tip to tip on the coax and ground to ground to make sure you got connections there. And if you have a short that shows up, it's not going to work. So that's it. Like I said, I had a printer that screwed up, but if somebody's super interested, I think I only have 5 of these. Does anybody want one?
All right, so crap. The cool tip I picked up is to use more heat.
Yeah.
Bigger iron and more heat.
Anybody else?
Perfect thing.
So like I said, I'm more than happy to do a workshop on soldering down the road, so we can, Daryl.
I think we have enough members, new members, that did really good at it.
Okay. So,
Nobody's going to admit they don't know how to do it, or somebody else.
yeah.
I suck at it. So what? Like what? So there's Ken on, he was on with college,
Oh, okay. So Chris is offering his place to have a little workshop on a Saturday or Saturday morning or something, or. So we'll talk about that and see if we can get it scheduled. So, anybody else? Any questions?
What's your opinion on the soldered ground versus ground?
I prefer soldering it. It's a better connection. But if you got a great set of crimpers and stuff, the crimp connections will last a good long while. But the thing's been my experience, the coax does not last forever, and that's people have more trouble with their radios and stuff, and they don't even troubleshoot their coax. And one thing you should always do, everybody should have a 50 ohm dummy load for 100 watt. That's a must-have for everybody. And so you take and put the dummy load on the end of your coax and get an SWR meter and hook it to your radio with the SWR meter from the radio to the coax, and then transmit, and it should be as flat as a pancake on reverse. Go ahead. Right. Yeah. Yep. That's a good idea. Right.
It goes up, say, a couple of rounds, but like one, two, there's something wrong.
Right. Right.
So usually get rid of 0.001, that's good.
I'll give you a good example on coax. There was a guy, he was a good friend of mine. He was a ham. He lived out by Dixon. He had 5 acres, and he had, I want to say he had 7 towers, and he was set up. He ran a 2-meter single sideband net every Sunday night, and he could reach LA and Portland, Oregon, no problem. He was running 2,000 watts or just under legal limit. And he had a gang set of 2-meter antennas, and they were all phased, and he could point them wherever. It looked like a bunch of machine guns. Anyway, he was having all kinds of trouble, and he was changing antennas, and he was changing this and that, and nothing seemed to fix it. So a friend of mine had a really good network analyzer, and we took it to his house one day, and we hooked the coax up to it. Coax was crap, and it was probably a 100-foot run or so to the tower to his house. So he put a new piece of coax on there, and it was working perfect. So always check coax.
That happened to us on field day. We set up a known antenna, ran the moderate length of coax. We've done it before. Just wouldn't tune in, took one piece out.
There you go. Yep. Yes.
My job, I find oxidized coax all
Yeah. Yep. Yep. Yeah. What do you do? Yeah. What do you do for a living? Okay. Yep. Yeah. Well, coax. Yeah, corrosional. Yep. Yeah, if you have long runs of coax, I highly recommend you put it inside PVC. That will solve a lot of issues for you. Go ahead. Yeah. Yeah. Yeah, it is. Sure. Mm-hmm. Okay. Yeah. Yeah. Mm-hmm. Yeah. Good idea. And then one last thing on since we're talking about coax is if you're hooking it up to your outside antenna, make darn sure you have a drip loop. Does everybody know what a drip loop is? Make darn sure, in case you don't know, so you hook it to your antenna and you don't want to run the coax straight up to it because water's going to come down, it's going to collect at that connector and it's going to get in there. So make a loop and then another loop back down, and that's your drip loop, and then it'll keep the water out for help. Gives you some extra, yeah, it gives you some extra to work with, right? Yep. So. Any other questions? Right, right. All right, well, I'll leave these handouts up here in case anybody wants another one. All right, well, thank you, guys.